Very good evening to all delegates. Am I audible to everyone?
Yes.
Thank you so much. A very good evening, ma'am.
Good evening. I think I'm audible.
Yes, ma'am, perfectly audible, ma'am. Welcome, ma'am.
Thank you. Thank
So,
you. Thank you so much.
a very good evening to all dignitaries, all faculty members, our respected resource person, Dr. Kalpana K. Mahajan, ma'am, and all delegates presented in today's live session of 3-month certificate program. It is my pleasure to introduce our esteemed resource person for today's online session, Dr. Kalpana K. Mahajan, ma'am. Ma'am has had an illustrious career served as a professor at the Department of Statistics at Panjab University, Chandigarh, until her superannuation on August 4, 2021. Ma'am has been an integral member of faculty in the Department of Statistics at Panjab University since 1977 to 78 and appointed as a professor in 2001 and served in this capacity until her retirement in 2021. Ma'am's research interests include inference, Bayesian inference, multiple comparison procedures, income inequalities, and environmental statistics. Ma'am has co-authored 6 books and 2 project reports and has published over 50 papers in leading international and national journals. Ma'am has guided a PhD and 16 MPhil students. Ma'am is on the regular panel of American Mathematical Society and several noted international journals such as Statistical Methodology, Communications in Statistics, and Computational Statistics. Ma'am has served on the editorial board of the International Journal of Statistics and Reliability Engineering, IJSRE, the International Journal of Statistics Theory and Application, IJS, and the Panjab University Research Journal Science. Additionally, ma'am has a guest editor for the Journal of Statistics and Applications. Ma'am has actively participated in numerous international and national seminars, conferences, and workshops, often serving as a keynote speaker, invited speaker, or section chair. Ma'am has delivered over 200 lectures and presentations since 2011. Ma'am has been on the program committee of the Global Science and Technology Forum, which organized international conference on operational research and statistics. Ma'am has also organized over 20 seminars, conferences, and workshops, including chairing the international conference of FIM 2012. Ma'am holds various numerous positions as a coordinator of UGC SAP DSA Department of Statistics from 2008 to March 2021, the chairperson head of the Department of Statistics from April 1991 to March 1994, and again in April 2009 to March 2012. Also a chairperson committee against sexual harassment in Panjab University in August 2010 to August 2013. Ma'am has been on the expert advisory committee of the UGC, IGNOU, and the Chandigarh region of Kendriya Vidyalayas. Ma'am has served on numerous selection committees for various universities and commissions such as PPSC, SSC, and JKSSC. Ma'am has also been a part of various academic bodies in Punjab University and other universities since 1980. Ma'am holds the position of life member of the International Indian Statistical Association, Indian Society for Probability and Statistics, and also Indian life member of Indian Society of Medical Statistics. Today, we are honored to have ma'am with us today and to share her expertise and experience with all delegates presented in this program. So without taking too much time, I would like to again welcome ma'am. Very good evening, ma'am, and welcome, ma'am.
Thank you so much. Thank you for the kind words, Dr. Amit Tiwari. I'm really thankful to you and the coordinators for associating me with your this mega project. Okay. So thank you so much. To let me start my talk, testing of difference, parametric tests. Okay. So as I was attending yesterday's lecture also, so just to see what type of basics you have done. So I'll be just revising them and then we'll go to the main topic, how to test different parameters, the difference of the parameters. So let me start with the soft note. When you talk about the statistics, you have different type of feelings in your mind. This is a very great saying that there are 3 types of lies, damn lies, and statistics. And then torture numbers and they will convey confess to anything. Statistics is the grammar of science. A single death is a tragedy, a million deaths is a statistics. So many quotes are there, and we just have made a compilation of Indian scholars during the corona time. This is statistics, so say Indian scholars. This is available on the YouTube, and you can go through this and see that how the statistics persons feel about the statistics, right? So 99% of all statistics only tell 49% of the story. But whether you appreciate statistics or you criticize it, you cannot survive without statistics, because data is all pervasive. You talk about any discipline, you see data will be there, whether it is sports, politics, economics, physics, chemistry, botany, national level, international levels, etc. So data is everywhere. So when you go for the collection of the data, or let us say data from around the person, you can collect the data on these variables. Okay, this is a very basic thing, but you go on just adding more variables into your data. For example, the basic thing will be you will be just note down the gender of the person, then employment status of the person, then marital status, family size, age, weight of father, and you can continue like this, like this blood pressure of the person, then family income, then expenditure, and so many things. So many variables can be put on this data sheet. Once you go for the, this is just an example, and I'll try to show you that how we can exploit different variables and go further decision, go for the inference, statistical inference, right? So this is a very simple data which we'll be considering again and again. Now, what is the basic purpose of statistics? When you talk about the statistics, everybody is talking about the statistics. I hope that all of you must be using the statistics. One more thing, if you have any question in between, you can just ask, or you can put your query in the chat box. Okay, I'll be very happy to answer that. So what is the basic purpose of statistics? Just you can, this is in the overall context, you can say the basic purpose of the statistics is to describe and to infer. That is how we can talk about the data in minimum possible terms. Or what is the typical message hidden in the data? Means to describe and infer. Describe and infer about individuals, institutes, processes, and phenomena. When it comes to the description part, you can just look at the data and give the answer that how many males are there in that data, how many female are there, how many of them are married, what is the average, like so, these types of questions. And when it comes to the inference part, can we say that more male than female attend classes? Or can we say that weight of the father is more than that of the son? Again, come to the data, and we can compile this data. The first thing is compilation. It is a gender-wise distribution of the class. Just note down the total number of males, females, and a table like this will be prepared. Okay? So then you can go for the frequency distribution. First thing is gender-wise distribution of the class, then frequency distribution of the class on the basis of employment status, and so many things, and then different distributions and tabular and graphic representations to describe this class. Then after compilation of this data, you can go for the measures, different measures of central tendency. All you have done, this is just we are revising the things and how we can compute these things from the data. The first thing, you will go for the measures of central tendency like arithmetic mean, median, mode, etc., to get a single representative value. And then use measures of dispersion, go for the measures of dispersion like range, quartile deviation, standard deviation, to supplement the measures of central tendency, as measure of central tendency may not reveal the true nature of the data. And similar will be the case techniques for bivariate and multivariate data. So description, in the description, the questions may be different and statements may be different. For instance, statement could be more female than male undertake refresher courses, or average weight of the persons attending classes is 65 kg, or is there any relation between age of the father and of his son? Look at the two statements and see the difference. One may say that more female than male attended the workshop, or one may say that more female than male attend the workshop. What is the difference? The first is describing complexion of the particular batch, and second is making a time and space free statement, a general statement, right? Now, if you come to the data, which we are just using again and again, let us say we want to make certain inferences with respect to the select one variable, that is weight. What type of inference you can make if you take one variable? You can take any variable in this data. So let us take weight as a variable. The first focus will be on the weight of the participants. Let us say the first is on the weight of the participants. And the question is, can we say the average weight of the participants is 65 kg? Very simple thing. From this variable, the first question will be, can we say the average weight of the participants is 65 kg? So in this case, we are comparing the average weight with 65 kg. This becomes the case one, comparing the average with the fixed value, right? Similarly, the same variable, weight of the participants, you can divide this data on weight into two groups, two independent groups. One is a group of female participants, another is a group of male participants, two independent groups. And we just want to see whether the weight of the female participants is same as the weight of the male participants, right? And the third case from the same variable will be before and after treatment. Same variable is given, weight of all the participants. So let us say some treatment is given to these participants, and then again their weight is recorded maybe after few days. And we want to see whether the weight is effective or not. So one variable, there can be three questions. Okay? So these are the three questions. And now other situations. See how we can use the inference part. What is the importance of this? Just take a simple example that a keen observer computes that the average content in 10 bottles of soft drink of a particular brand was 295 ml with the standard deviation 5 ml. Let us say a person goes to the market and he wants to purchase a certain brand of soft drink, and he just picks 10 bottles out of that lot and found that the average weight comes out to be 295 ml with the standard deviation of 5 ml, right? What he does? He files a case against company on cheating. But company justifies its production, saying that contents supplied are as per specifications. The average weight is 300 ml with the standard deviation of 10 ml. The specifications made by the company is that average should be 300 ml with the standard deviation, with the variation is 10 ml. So let us say he collects another data, two samples. The first one gives 295 ml as an average weight, and the second one, in the second sample, again from the same lot, he gets a second sample of 10 bottles, and this gives the average content of say 305 ml with a standard deviation of 5 ml. See the variation. Now, in both the cases, company justifies that the product is as per the specifications. The average content is 300 ml with a standard deviation of 10 ml. Now, where is the catch? There are two samples. In the first case, the average comes out to be 295 ml. In the second case, it comes out to be 305 ml. The variation. Why this variation? The variation could be due to cause and effect. Maybe some reason may be there during that process, during the packing process and so. And if some reason is there, that should be located. But otherwise, this variation is by chance. What is that chance factor? Chance is due to sampling. In the first sample, he is getting less. In the second sample, he is getting more. But in both the cases, company says the product is a good quality product with the as per the specifications, right? Now, what is the message from these examples? What do we get from these examples? Based on the sample observations, we take decision for the population about the total. Just on the basis of few observations, we decide about the population. How to decide? The statistical analysis is carried out to draw inference about population on the basis of samples collected from the population. Right? Now, how to test? How to get the answers of these questions? When this type of question comes, the simple answer given by the students is that we can use TF ANOVA. Of course, these are very popular tests. T-test is, you know, that this is used for testing the population means, the difference of the population means, and like that. And ANOVA is analysis of variance is used when we are comparing more than three variables, three or more variables. And if the sample size is large, we can go for Z test, the normal test, and the other tests are chi-square test and F test. These are the very common tests. The simple answer will be that we can test all these situations by using TF ANOVA. But the problem is how to choose the right statistical test. In which situation, which test should be applied? Of course, we know the answer that our test will be one of these tests. T, Z, chi-square, ANOVA, F test, etc. But in which situation, which test is to be applied? So choosing the right statistical test depends upon the first thing is you have to understand the nature of the data, means the distribution of the data. What type of distribution is there? Yesterday, a lot of discussion was done on the distribution about the normality. Generally, we assume the distribution is normal. If it is normal, then it is okay. You can go for TF ANOVA. But if it is not normal, then what to do? If it is not normal, we have an alternative sets of techniques available. The techniques which are used for the normal distribution, they are parametric techniques. And techniques which are used in the absence of normality of the distribution of the population are non-parametric techniques. Of course, you will be covering all these techniques, and in today's lecture, we will be focusing on the parametric techniques. So the first assumption is regarding the nature of the data. And then what are the sample characteristics you can find out from the data? We'll see that what are the characteristics, what is the definition of this. And lastly, the inferences to be made. What type of decision you want to make? What is your research question? Right? So these three are the basic things in order to select the right statistical test. Okay. Now, when it comes to the inference, so we'll quickly revise what are the fundamental terms which are used in the statistical inference. The first thing is statistics and parameters, then statistical hypothesis, then errors, and then test statistics. Okay. So when you talk about the statistics, the word statistics, if you understand this word in plural sense, it means data. In singular sense, this is a subject. Otherwise, statistics is a list formulas. They are also called statistics. And in inference, statistics is nothing but the characteristics of the sample. So this is again one effort made by us, the world of word statistics. If you find time, you can go through these small movies, this videos available on YouTube, the world of word statistics. Okay? So different definitions of statistics you can find out in this. Okay? So now statistics here is the characteristics of sample. So what is the difference between statistics and parameters? The statistical generalizations are carried out to settle for some knowledge about certain characteristics of a population on the basis of sample drawn from the population. Okay? So then there must be some characteristics for the population also, some characteristics of the sample also. So just to avoid the confusion about whose characteristics we are focusing, we refer to the characteristics of the population as parameters, while that of the sample as statistics, right? So we are mostly interested in the population rather than outcome of a particular sample. Clear? And usually population is unattainable, very large. So the characteristics of the population, that is parameters, are usually unknown, but they are fixed, they are constants, right? But when we select a sample and on the basis of characteristics of the sample, we tend to draw inferences about the parameters. This is what is the procedure. On the basis of the sample, we tend to draw the inference about the parameters. Okay? So now, the thing is that statistics being based on samples is likely to vary with samples. We can have different samples from one population. So many samples can be there. So many these characteristics of the sample are there. So many statistics will be there. Then what to do? How to use these things? Okay, so we'll see this later, that how these different um, statistics are used to get the decision, to get the inference. Okay, there comes the concept of standard error and all we'll be discussing after this, because these things will be used in the formation of the statistics. Now, what are the statistical hypotheses? Of course, a lot of discussion has been done on this, but just in the revising this, a statistical hypothesis is a statement about the population, precisely about parameters. When you know the population, the distribution of the population, you can always state the hypothesis in terms of parameters. See, here we are talking about the parametric inference, parametric test. Okay? So we know the distribution of the population. So we know the parameters of the distribution. Okay, so hypothesis is nothing but a statement about the parameters of the distribution. Now, next thing is a statistical hypothesis may be simple or composite. What is this simple and composite? A simple hypothesis may be defined as the one which gives a complete specification of a probability distribution. Everything is completely specified under the simple hypothesis. Just take a simple example. When we say that x, the random variable x, is normally distributed with the mean 60 and standard deviation 10, it means it describes the complete distribution, right? Everything is clear. The mean is 60 and standard deviation is 10. But when we say the fraction defectives in an output is less than or equal to 10%, then what? This is a case of composite hypothesis, as it contains two or more elements of the parameter set. Any value which is less than 10% will give you different distribution. So this hypothesis is not specifying the distribution completely. If the distribution is completely specified, then the hypothesis is simple. If it is not completely specified, then the hypothesis is known as a composite hypothesis. Yeah. So now, how to frame the hypothesis? How to take the decision? So your decision will always depend upon the selection of either of two courses of actions. And in testing procedure, attention is thus focused on two possible sets of values of the parameters or two statistical hypotheses. So such a pair of hypotheses are called null hypothesis and alternative hypothesis. Two courses of actions. Either you will be going for null hypothesis or you will be going for alternative hypothesis. So always frame two hypotheses. So the designation of null and alternative hypotheses are arbitrary. But how to select the null hypothesis? The null hypothesis conventionally is specified in an exact manner, and it usually corresponds to the absence of effects of the variable being investigated. Just null, no difference. So null hypothesis should always be a hypothesis of no difference. Whatever you want to check, that you can put in the alternative hypothesis. Suppose look at this example, we wish to decide whether one procedure is better than another. So how to formulate the hypothesis? In this case, again, the null hypothesis will be no difference hypothesis. We'll frame the hypothesis that both the procedures are equally good, right? So null hypothesis should always be framed in an exact manner. Of course, there is a statistical reason behind this. You fix the value, just one value, and it will be easy to find out the distribution of the test statistics if a hypothesis of no difference is used. But if you use the alternative, all other things will come under the alternative hypothesis, and you cannot find out the distribution under, because there will be so many values. You have to find out the distribution at all these values, right? And so there can be so many alternative hypotheses for one null hypothesis. Suppose in this example, our null hypothesis will be P, the fraction defective, is equal to 0.4. Let us say this is the null hypothesis. What are the possible alternatives? The first alternative, which is denoted by, let us say, HA, or you can denote it by H1, then H2, then H3. Any notation can be used for the alternative hypothesis. But for the null hypothesis, you have to write down H0, no, null, right? So for one null hypothesis, all the possible alternatives are there. P is not equal to 0.40, simple, two-sided hypothesis, right? You have discussed this two-sided, two-tailed hypothesis, two-tailed test rather, okay? And the second one will be, we can say the fraction defective is more than 0.4. And the third one is it is less than 0.4. Okay, so all these things can be put under the alternative hypothesis. Null hypothesis should be always framed in an exact manner. The hypothesis of no difference is called a null hypothesis. Then comes the errors. What are the errors involved in the testing? So you know that two types of errors are always involved. A lot of discussion was done yesterday on the errors. And the whole testing is based on these errors. We just try to minimize the errors, right? Just try to understand this from the table. Let us say the null hypothesis is true. Go to the example where we had an example of soft drink content, and let us say the product was good and you accept that. This is a correct decision. The product was okay and you have accepted that. But let us say, just on the basis of the sampling as it was there in the first example, that average came out to be a little less, and you are just going to reject the null hypothesis. You are just going to reject the lot. You are tempted to reject the lot. Of course, it was true. It was a good lot. Of course, it was a good thing, but you reject that. It means you are committing a type 1 error. A good thing is rejected, type 1 error. But in the second case, let us say in the second example, the average of the 10 bottles came out to be more, and you just accept that. You just accept the lot. It means, but the lot was not good. You are committing type 2 error. In the first case, you are rejecting the good one. In the second error, you are accepting the bad one. So it is clear that type 2 error is more dangerous than the type 1 error. Of course, we'll try to minimize these errors, or the risks of these errors should be minimized. Both the errors should be minimized. Okay, but which one is more dangerous? That is to be taken. More care is to be taken regarding the type 2 error. And the probabilities of committing these two errors, type 1 error and type 2 errors, are considered as the risks of. Yes, yes. Anyone, please? Do you have any question? Okay. So if you have any question, you
Anyone
can
need
just
to ask
stop me.
anything, then please.
If something is not clear, you can just put this in the chat box, or you can ask the question. No problem. We can discuss even after the time also. Okay. So I think you don't have any other lecture after this lecture,
No,
right?
no lecture is there, ma'am.
No lecture,
Yes,
or
yes,
your
yes.
lecture is there after this?
No.
Okay,
After this,
then we have enough time.
yes.
So you can discuss anything. Okay, no problem. If something is not clear, you just ask at that time only. Okay, just a chat box is also opened in front of me. I can just go through that and answer your queries, right? So now the probabilities of committing type 1 and type 2 errors are considered at the risks of wrong decision. And our aim is to minimize errors in our test of hypothesis. Yeah. Now, to minimize the errors in our test of hypothesis, this is again not very simple, because for a given sample size, an attempt to decrease type 1 error results in an increase in type 2 error and vice versa. So a balance is to be made. Okay? So what is level of significance? Again, this word is used in testing of hypothesis. The probability of type 1 error is also known as level of significance of the test, and it is denoted by alpha, right? And probability of rejecting H naught, accepting H naught when it is false is beta. The risk of type 2 error, alpha and beta. Of course, a word gamma is also used, that is 1 minus beta. Okay? So now what we like to do, because type 2 error is more dangerous, so by fixing the risk of type 1 error, we'll try to minimize the risk of type 2 error. We'll try to minimize beta. Clear? Fixing alpha, just fix at some level, maybe at 5% level, maybe at 1% level, not more than that. What is the meaning of this 5% level or 1% level? In testing of hypothesis, the level of significance are usually taken to be 5% and 1%. So means when we take 5% level of significance, means alpha is 0.05. It means we are 95% confident that we have made the right decision. And if it is 1% level, it means we are 99% confident we have made the right decision. So normally we take this as 5% level. Okay. Then comes the, this is regarding the errors. Then standard error. This is different from these two errors. Type 1 error and type 2 error. Now forget about that. Come to the term standard error, because this standard error is used in the formation of the test statistics. Of course, you don't have to go for the mathematics involved in this, but you must have the idea that someone may ask that how to frame these statistics. We are testing this hypothesis and all of a sudden you name Z, T, chi-square and all. How do we get these statistics? Okay. So in these, the formation of these statistics, we use the concept of standard error. What is the standard error? As you have seen that when we are discussing that the sample characteristics, they vary from sample to sample, but the population characteristics, they are fixed. Okay. So we take the help of sample characteristics to take the decision about the population. But how many samples can be there from one population? So many samples can be there. So many parameters, so many, you can say the values or so many characteristics, this values will be there for the same parameter, right? See here, if we have a population of size n, capital N, and we want to select a sample of size small n, how many samples can be selected? NCN. And for every sample, you will be computing the statistics. Let us say we need X bar and variance, S square, etc. So many statistics can be there. Let us concentrate on mean and variance. So for every sample, X bar and variance will be different. For every sample, these values will vary. How to use them? We want to ultimately estimate, or we want to decide something about the population characteristics. But we are having so many samples and we are getting so many characteristics. So in order to, for example, this is a small example. Let us say we have data of 5 observations. This is very simple. Of course, in the population, we'll have more values. Just to get it clear, let us take we have 5 observations and we want to select the sample of size 3 out of this 5. So how many ways you can select the sample of size 3? 10C, 5C3. So 5C3 means we will have 10 samples. We can have 10 samples out of this population of 5. So we'll have 10 means. We'll have 10 means from this population. So then how to tackle these means? Just these means can be grouped into a frequency distribution. Of course, this is a very small sample. When a large sample will be there, you will be having more values, more means will be there. So just make a frequency distribution table of this, and the frequency distribution of the statistics is known as the sampling distribution of the statistics. एक population distribution होता है, एक sampling distribution होता है. Population distribution, you know, you can check from which distribution the population follows which distribution. But the sampling distribution will be for the different samples which are obtained from that population. Okay, that is called sampling distributions. And the standard error is the standard deviation of the sampling distribution of the statistics. Right? What is the standard error? This is not the two types of errors in testing. Standard error will be used in the formation of the test statistics. This is nothing but the standard deviation of the sampling distribution of the statistics. Right? You always say the test statistics follows T distribution, it follows F distribution, it follows Z distribution. This is a sampling distribution. Right? So standard deviation of the sampling distribution is the standard error. Now, this is a simple background in the formation of any statistics. Whenever you go for any hypothesis testing, normally we define Z for large samples. When we are considering the large samples, then Z statistics will be defined as T minus expected value of T upon standard error of T, the general definition. Where T is any statistics, let us say mean of the population, mean of the sample, or the mean of the population, any statistics. So statistics is the characteristic of the sample. So T is any statistics, and expected value of T is expected mean of the T, the population mean. And standard error of T, SCT, is standard error of T. So if you know these three things, you can get the test statistics and you can get the distribution of the test statistics, because this Z will always follow a normal distribution with mean 0 and variance 1. See, this is for large samples. Of course, for small samples also, you can frame the test statistics and there you can find out the exact distribution. Here, this is the mathematics behind these things, but these days, once you know that which statistics is to be used for which problem, you can directly go to different softwares. I think you will be having lectures on different softwares also. I am not going to touch these softwares, but once you know that which test is to be used, you just open your data sheet in that software, click on the procedure, click on the test which you want to use, and you will be getting the result within few seconds. But you have to decide about the statistics. You have to decide about the test, which test is appropriate for your problem, for your variables, right? This is just mathematics behind the formation of the test statistics. Okay, then how to take the decision? This is again very important. आपने value compute करनी by using that test statistics mathematically. Of course, this theoretically, the software will automatically give you the decision. There also you should know the technique, that how to take the decision, which value is to be used for taking the decision if you go for different software. But theoretically, let us say we decide to take our decision at 5% level of significance. Then if it is a normal distribution, if the test statistics follows a normal distribution, the value of the Z, the tabulated value of the Z will be 1.96. If you look at the statistical tables, you will be getting this value. And our test procedure states that if the difference between the observed and expected value of t, or if the value of that test statistics z, which you have just seen, this one, if it comes out to be less than 1.96, then you just go for the acceptance for the null hypothesis. But if the value comes out to be more than 1.96 times the standard error of t, the null hypothesis is rejected at 5% level of significance. Right? 1.96 is the value at 5% level of significance. Okay. Then p-value. Another concept is, if you are going to use some software, there you are not going to use the tables. आपको tables नहीं use करना. There the concept of p-value is used. You just look at the p-value, and if your p-value comes out to be less than the level of significance, means 0.05, you reject the null hypothesis. If the value comes out to be greater than 0.05, you go for the acceptance of the null hypothesis. Don't reject the null hypothesis. So p-value will be seen from the software whenever you apply any test statistics. P-value, normally if you are using SPSS, it is written as significant value, SIG value. So SIG value is p-value. Just look at that value and compare this with the level of significance. That will give you the decision, right? Now, before we proceed with specific tests, for the practical purposes, if the sample size is greater than 30, it is considered as a large sample. Then all these tests, they become normal. For example, the t-test, which is a very common test, it becomes normal test. So in the software, you have to select the t-test. Automatically, it becomes normal, because if the sample size is more than 30, it will be using normal critical values, right? Now, the first thing is tests concerning proportions. Proportions, I'll not concentrate more, just to give you an idea that you can test as a fraction defective hai, how much your that medicine is affected. Claim is made by the this manufacturer, and you want to check that medicine is given to a few patients, and then it is checked whether it is effective or not. Okay, how many patients are cured by taking this medicine? Okay, in medical field, we go for the proportions, for tests related with the proportions. Just single medicine is effective or not, and you can compare the performance of the two or more medicines. Like in clinical trials, we can go for these tests. Okay. This is just because what will be the result when the medicine is given? Either it will be effective or it will not be effective. So we'll have a Bernoulli variates. The variable can take only two values, 0 or 1, yes or no, success or no success, etc. So in this case, we define the probability of success as P, probability of 1 as P, and probability of that missing this effect as 0 as Q. Okay, so it means the whole group, the whole population can be divided into two groups. One is those who are successful persons, and the other one are failures. Okay, so this is, we are just considering the same theory, how to frame the test statistics, because this is just a binomial distribution will be there, and of course a theoretical things are there, and these things are also available. The tests are available on different softwares like crosstabs and all, when you want to check these proportions, etc. But the basic theory behind these is that you have to frame the test statistics by taking z as x minus expected value of x upon standard error of x. Once you don't know the distribution of this test statistics is binomial, distribution of x upon and proportion of success is binomial, you can find out the expected value of x and standard error of x. And finally, the test statistics will be z, which will be normally distributed with mean 0 and variance 1. And you can just go for the normal tables like values, and compare your computed value with the tabulated value, and this is some values which will just you can use these values to decide about the hypothesis. If your z values, if your z value falls between -3 and 3, this probability is 0.9973. Okay, so in this case, the probability that your variable lies between -3 and 3 is very high, 0.99. And at the same time, if you are considering this is more than 0.1% level of significance, so upper and lower limit is -3 and 3. If your value exceeds 3, let us say, so you will just go for the rejection of the hypothesis. No need to see the tables even. Value इतनी large आ गई है कि you are just rejecting the null hypothesis. But if your value lies between -1.96 to 1.96 ही होगा 1.96, then if your the value of the statistics is less than 1.96, it means you are accepting the null hypothesis. Of course, we don't use this word accept the null hypothesis because this is a very strong statement. Accepting means the exact value you are accepting. The value, when you are talking about 95% confident, the value which is very close to the true value can also be accepted. Okay, and when it is 1% level of significance, the value of the test statistic should lie between -2.58 to 2.58. And if your value is smaller than this 2.58 or absolute value of z is less than 2.58, you accept the null hypothesis, you go for the null hypothesis. Okay, so ये 5% level है or 1% level है, like that only. If z is absolute value of z is greater than 3, the null hypothesis is always rejected. If absolute value of z is greater than 1.96, it means the null hypothesis is rejected at 5% level of significance. If your absolute value of z is greater than 2.58, it means you are rejecting it at 1% level of significance. Clear? Now, what are the testing situations? Again, come to the same data which we had taken earlier, and see the different testing situations. At times, we may be interested to test if the sample mean differs significantly from a hypothetical value of the population mean. If the given sample has been drawn from a population with a specific mean is already there, given mean, and you want to check that your sample has been drawn from that or not. Okay. If the two population means differ significantly or not. If the given sample has been drawn from a population with a specific variance. So many situations. These are few of the testing situations which I am listing. Or if the two population variances differ significantly or not. Similarly, test for proportions and all. Now, what are the steps in testing? How to go for testing? Now you know that we have to use one of these tests. Then what should be the procedure? Okay. The first thing is look at the data, look at the distribution, look at the assumptions. What is the whether it is normal or not? If it is normal, go for these parametric tests. If it is not normal, go for non-parametric test. The first thing is look at the assumptions. Then state a null hypothesis. State an alternative hypothesis. Once null hypothesis is there, accordingly you can write down the alternative hypothesis. Now define a test statistics along with its distribution under the null hypothesis. ये next step है. For this problem, now your null hypothesis is clear, which parameter you are testing, population parameters you are testing. So you can always define a test statistics, and then what is the distribution of the test statistics under the null hypothesis. Why under the null hypothesis? Because you will be using the fixed value of the null hypothesis in the test statistics, in the computation of the test statistics, right? Then compute the value of test statistics from the information given in the sample data. Theoretically, okay? Of course, if you are using software, you know the test statistics, put your data there, open the software, click on that test procedure and get the value. But theoretically, you have to compute the value of the test statistics and then compare this value with the tabulated value, with the theoretical value, and decide about the rejection or non-rejection of the null hypothesis. We don't use word rejection and acceptance. Rejection and non-rejection of the null hypothesis at predefined level of significance. Okay. So this is the general technique which you have already discussed, and another will be by using the p-values. You have to take the decision. If your p-value comes out to be less than 0.05, you reject the null hypothesis. If p-value comes out to be more than 0.05, you go for the non-rejection of the null hypothesis, right? Now come to the T statistics, which is the very popular statistics, and everybody uses this. Okay, so why this? Where it is used? I'm talking about the mean, the average. So in the context of average, how this T statistics is used. Of course, this T statistics is used in other situations also, like testing of correlation. ये आपका जब correlation का topic होगा, तो there they will be discussing for regression, for correlation. Again, there will be using T test. Now, here the T test is used to test hypothesis about means when the population variance is unknown, right? So the assumption is the sample is drawn from the normally distributed population with unknown variance. We go for t-test. And if the sample size is large and variance is known, we'll go for z-test, the normal test. And this t-test is developed by Gossett for the quality control of beer. And it comes in when we talk about the means, it comes in three varieties: single sample mean, independent sample means, and dependent samples mean, right? Formula is slightly different for each: single sample, paired sample, and independent samples. Okay, so this is all these things we have already discussed. Test whether a sample mean is significantly different from a pre-existing value. और paired sample में test the relationship between the two linked samples, means obtained in two conditions by a single group of participants, paired samples हैं, and independent samples between testing the means between the two independent samples. Now again come to the data which we are using and the variable which we are focusing. Could average weight be said to be 65 kg? The first thing is from this data, we'll be checking the normality. Check the assumptions. Assumptions is regarding the normality. Of course, if the sample variance is normally unknown and you go, when you use the T statistics, you compute the variance from the data itself. Okay, so normality कैसे check की जाती है? This is if you get a curve close to this type of shape, you say this is normal. Of course, so many plots are there which can give you the normality, and of course, so many tests are also there. So many goodness of fit tests are also there, which you will be doing in non-parametric inference, how to check whether the distribution of the this population is normal or not, right? Okay, then you state the hypothesis. आपने assumptions देख ली. The first step is clear. Now go for the null hypothesis. That our question is that could average weight be said to be 65 kg? So null hypothesis will be clearly that mu is equal to 65 kg. Mu is the population characteristics, the population parameter. On the basis of our sample, we want to check whether the population mean is 65 kg or not. Now, alternative, it depends upon your problem. Whether you want to check that it should be more than 65, it should be less than 65, or generally two-sided, it is not equal to 65. Clear? Then for this situation, we look at the level of significance, and for this mean, we'll go for the test statistics T. And we know the distribution of T is T distribution with n minus 1 degrees of freedom. Then the second case is comparing the averages, comparing the means of the two groups of persons, male and female, whether the average weight of the male participants is same as the average weight of the female participants, and then you can frame the alternative hypothesis also. Okay, and the third case will be, this is the how to frame the null hypothesis in the two independent samples case. Mu f is equal to mu m, and alternative, simple two-sided alternative is it is not equal to, and one-sided it depends what type of alternative you want. Then go for level of significance and test statistics, and this test statistics will be known as t-test for two independent samples, right? Then the third case is before and after the treatment. Some related observations will be there. Maybe in this case we can check the weight of the father and weight of the son also, whether these are the pair, because number of observations in that will be same. Whereas in two independent samples, t-test for two independent samples, the sample sizes may be different. But in paired, because they are dependent samples, they are not independent, so the number of observations will be same in both the samples. Okay, so in this case, how to state the null hypothesis in paired comparison before and after the treatment? Mu d is equal to 0, means the difference, mean of the difference is equal to 0. Before the treatment, after the treatment, mean before the treatment, mean after the treatment, that difference is equal to 0. And of course, alternative is, again you can write any one of the three alternatives. The simplest one is two-sided, mu d is not equal to 0. And if you want to see the treatment is effective, accordingly you can frame the hypothesis. Treatment effective means if it is the medicine is given, the treatment is given for the improvement of this weight, then definitely the after mean should be greater than the before mean. Okay, so mu d will be equal to mu d. How do you define d? That will give you the alternative hypothesis. Xi minus yi liya apne, so mu d will be less than 0, because after the treatment you are saying the weight increases. Okay, so accordingly you can frame the alternative hypothesis. Then again you have to go for the paired t-test statistics, right? So just we'll be just taking one or two simple examples how we can use this theoretically. Of course, practically, otherwise normally what I do all these problems simultaneously on the software also, so that it is clear that once the data is with you, then how to compute the value of the test statistics from the software. But now, because you have separate lectures for the software, so I'm here just considering a very simple problem for applying the t-test. So let us check the mean cholesterol hypertensive man. The data is collected on the mean cholesterol hypertensive man and mean cholesterol in male general population from 20 to 4 years old. Okay, so this is what is the statement, what is the claim which is given. The claim is given that the mean serum cholesterol is 211 mg with a standard deviation of 46 mg. Hypertensive men के ऊपर data collect किया गया, and in the group all the men from the 20 to 74 year were there, and the claim is that the mean cholesterol should be 211 with the standard deviation of 46 mg, and we want to check whether this claim is correct or not. Here in this case, what will be our null hypothesis? We want to check that mu is equal to 211 mg or not. Means population mean serum cholesterol for male hypertensive men is equal to 211. And alternative is, it is not 211. Simple two-sided alternative. Right? Now, definitely a sample will be there. Maybe 10, 15 observations you will be there. You will be having from this group of persons, and you can compute the sample characteristic. Just one sample, X bar compute karenge, and then you will be using this test statistics. Of course, the continuous outcome will be there. You know the continuous outcome. It can take any value within some range. And variance is unknown. Of course, we are not having any idea about the variance. So the statistics used will be X bar minus mu naught upon S under root of n, S upon under root of n, which will follow T distribution with n minus 1 degrees of freedom. So compute this statistics and get the critical values. If you are not getting the p-value, get the critical values from the statistics books or computer. This follows t distribution, which is approximately normal for degrees of freedom more than 30. The test statistics. So let us say we have a data. The data I have not written here. So from the data, X bar is computed to be 220. We have 25 observations. Let us say 25 observations are given and data is there for all the 25 men. And in the statistics, when you put the value 220 is the mean of the this is sample characteristic. आपने sample में से mean compute किया, it comes out to be 220 minus 211, which is claimed in this hypertensive man, and S is computed from again from the 25 observations, from the given 25 observation. And if you get this value of statistics, compute this value of statistics, it comes out to be 1.17. Okay. Now for alpha is equal to 0.05, two-sided test from t n minus 1 degrees of freedom is 24. The critical value, this is seen from the t tables, it comes out to be 2.064. Right? So your value, your computed value is smaller than this tabulated value. That means difference is not statistically significant. See this language, we must write that difference is not statistically significant. If the value comes out to be more than 2.064, then we'll say the difference is statistically significant at this level of significance. So we fail to reject the null hypothesis. So whatever claim is there, that is correct. Yeah? This is how theoretically we use the statistics. Theoretically, we interpret the results. Then again, we can get the confidence intervals also. Of course, from the software, you can easily get these values. ये values आपको difference की दी जाएंगी, तो वहाँ पे जो software में confidence interval आता है. But here the value is given for the what is serum cholesterol level. If it falls between this 204 to 235, it is acceptable. The claim is justified, right? So a single sample t-test is quite easy to understand, as you have seen that it is not difficult, but it is rarely used in practice. Why? Because we do not often have a population mean to compare. ऐसा कभी हुआ कि आपका you know the population mean? No. Right? So we don't use this statistics in practice. Okay? The more common situation is to compare two different samples of subjects in order to decide if they come from the same population. Two sample पे जाएंगे हम. Okay. So for the two sample, again theoretically we have two sample sizes, independent samples. We may have different number of observations in both the samples, let us say N1 and N2. And of course, these are drawn from normal or approximately normal populations whose standard deviations are equal. Here another assumption is made. Standard deviations are equal, variances are equal. See, whenever you use any software also, there also you have to take care of this assumption. Two sample independent tests आप use करेंगे. There in SPSS, one column will be where the equal variance assumed, another one will be where equal variance not assumed. So first he will test that. First in the software, the test will be done for checking the equal variability. If equal variability will be there, then different value will come. If equal variability is not there, then value will be different. Right? So assumption you have to check first. Right? Here we are assuming that the variances, the standard deviations of the two samples are equal. Of course, we know the mean of the first sample, mean of the second sample, and let S1 and S2 bear the respective standard deviations. So if we wish to test the null hypothesis that the samples come from the same population, we use the test statistics. पहले तो आपका null हो जाएगा mu1 is equal to mu2. Means there is no difference. No difference between the groups. So here our title was that testing the hypothesis of no difference. So it means The null hypothesis is a hypothesis of no difference between the groups against the alternative that mu1 is not equal to mu2. There is a significant difference between the groups. Here we are just taking two-sided alternative. You can take one-sided also as per your requirement. Then the test statistics, theoretically, this will be the test statistics which will be used for testing this hypothesis. You have these values with u x1 bar minus x2 bar. S is the pooled variance, pooled standard deviation. 1 upon n1. N1 is the sample size of the first sample, N2 is the sample size of the second sample. So S square is this one. Of course, you can get these things from any book or any on the net. But the thing is that how to apply this value, how to use this value. So theoretically, put these values, you will be getting the value of T, compute that value, and of course, the distribution of this test statistics is again T distribution, students T distribution with N1 plus N2 minus 2 degrees of freedom. The two fundamental assumptions are made. What were they? Parent populations from which the samples have been drawn are normal. The population variances are equal. Of course, we have test statistics for unequal variances also. So a simple problem, again, just to clear about this test statistics, a psychologist wishes to compare the intelligence quotient of students in the courses of law and commerce, and this is the data which is given. Sample size है, the first commerce students, there are 16 commerce students and 11 law students, and the mean of these scores, this IQ level of this commerce students is 114 and law students is 109, and these are the standard deviations which are computed from the given data. And what do we want to check? Can we, on the basis of above data, conclude that there is no significant difference between that IQs of the students in the two courses? See, no significant difference. In null hypothesis have got no significant difference. Clear? So this is the table, values are given, and just test this hypothesis and see here the standard deviations are of course not same, but assumption given is that the variation in the two groups are same. So this is just by using, by stating the null hypothesis, by stating the alternative hypothesis, and this is the test statistics. The value comes out to be 8.57. Here, this is the value of the variance, value of the standard deviation, the standard error. Okay, and if you put all these values, the value of T comes out to be 1.50, and from the table, because here we are just doing it manually, we'll get the value of the table from how many degrees of freedom? N1 plus N2 minus 2 degrees of freedom means 25 degrees of freedom. 16 plus 11 are the total number, N1 plus N2 minus 2 degrees of freedom is 25 degrees of freedom. Since the calculated value of T, जो आपकी आई है 1.50 at 5% level of significance is smaller than this 2.06. So how will you interpret this result? Your calculated value is smaller than the tabulated value, so we do not reject the null hypothesis and conclude that there is no significant difference in the IQ scores of the students in two courses. No significant difference, right? So this is just again writing this thing. We can have the same variance, we can have different variance, both the variance known, variance unknown. If variance known है, sample sizes are large हैं, तो अब Z test use करेंगे. Z is automatically normal 0 1, and then if it is to be calculated from the data not known, then these statistics will be used. Okay. Known variance है, common variance है, then this will be there. Unknown है तो pooled variance लेंगे हम. And then this is regarding the paired t-test. Paired t-test में your statistics will be just on the basis of the difference. You just from xi yi compute di. Di is xi minus yi and frame the hypothesis mu d is equal to 0 versus mu d is not equal to 0, and this is again T and Z test can be used. For large samples you can go for Z test, and for small samples you can go for T test. जब आप सॉफ्टवेयर में जाते हैं तो there they don't consider large and small, automatically gives you the value. They always say that use the T test. You have to go for the T test whether you are using 70 80 observations and so on. because automatically that will become a normal distribution. Okay, हो गया आपका. Now another thing is, after comparing the two means, single mean, two means, now you can go for more than two means. This is called analysis of variance. Here, analysis of variance is used to determine whether there are any statistical significant differences between the means of two or more independent groups. Independent populations है normally two or more, not two. It should be three or more. 2 पे तो t test आ गया, t test for two independent variables. If we are having more than two groups, then we go for ANOVA, analysis of variance. This is also a very popular technique used by the medical students and social sciences students and all, by statistics people, analysis of variance, because we always compare more than two variables at a time, right? कल क्लिनिकल ट्रायल्स की बात कर रहे थे, देयर यू मेनली गो फॉर एनालिसिस ऑफ वेरिएंस. दे व्हेन दे साइमल्टेनियसली कंपेयर द इफेक्ट ऑफ सो मेनी medicines, they go for analysis of variance, one way analysis of variance. This is one way analysis of variance. Okay, so simple exam performance differed based on text anxiety levels among students, dividing students into three levels, three independent groups. Low anxiety level, medium anxiety level, and high stress students are there. Okay, and their performance is recorded, and we want to check whether the performance of the three groups of students is same or not, whether there is any significant difference between the performance of the students or not, three group of students or not. So here we are concerned about the three means, mu1 is equal to mu2 is equal to mu3. Okay, so this is again, the variable should be measured at the interval or ratio scale. आपके पास observations होनी चाहिए, continuous observations, data, you know the data. If it is in ranking, then we cannot use, if it is on the ordinal scale, then we cannot use ANOVA, then we will have to go for the non-parametric analog to this test. Okay, then of course independence of observations are there. All these observations, they are independent of themselves within the groups and between the groups. And of course this assumption is very important, there should be no significant outliers. Rather, this is important when you go for using any test, because a single outlier will spoil your result. Sometimes that value may be true, ऐसा नहीं है कि गलती से वो नोट हो गई. That value may, for example, if we are just considering the data on the weights, maybe 1 or 2 persons are there who are very heavy weights. The rest of the students, they are just normal. So these two persons or one person will just spoil the whole representative value. Clear? So first of all, whenever you go for any test procedure, you just check the outliers, okay, in your data. Remove these outliers, then go for testing. Otherwise आपका जो testing है वो that will not work. Okay? Yeah. So this is again the assumptions. Assumptions क्या है? Variables should be approximately normally distributed for each category of the independent variables. You have different categories, different, if you are having three sets of variables are there, and all should have normal distribution. Then homogeneity of variances. Homogeneity of variances कैसे check करेंगे? Means we are saying that the variances are equal for these three groups. This is assumption, but you can always test that manually. Of course this will not be very easy for you, but you can go for this software, and first of all check this thing. Leibniz test for homogeneity of variances is there in SPSS. First check this thing. If you see that no significant difference in the variances is there, then go for this ANOVA. If data fails this assumption, equal variance is not there, then Welch ANOVA, the option of Welch ANOVA is also there. Welch ANOVA instead of a one-way ANOVA, and also use a different post hoc test. Post hoc test क्या होते हैं? Once you reject the null hypothesis that all the means are not equal, आपने reject कर दिया, there is a significant difference between the means, then maybe any two of them have same mean. If let us say you are talking about the three means, 1, 2, 3, maybe 1 and 2 are same, third one is different. or 1 and 3 is same and 2 and 3 is different. So you have to compare all these pairs. In 3 case, of course, these will be 3 pairs, but if you have more, you will be having more pairs, and automatically these software detect the sample, that variable which is not comparable with the rest of the variables. So you can easily delete that, so that your variables, all these variables will be comparable. Okay, so Welch ANOVA or ANOVA for post hoc tests. So ANOVA, this analysis of variance will give you that regarding more than 2 means. Clear? So I think I can take 10 minutes more, 5-10 minutes more, so we can talk about the variability also. Means tests are over. Mean test we have done. Parametric tests are over. Anyone? Are you there? Hello?
Yes, ma'am.
So I can take 10 more minutes.
Yeah, definitely, ma'am. Sure,
Yes,
ma'am.
sir.
So we'll go for the variance also, because
All delegates are
variability.
there. They can unmute at their end. I allowed everyone. If any doubt, you can ask after the session, and you can write in the chat box also. I allowed
Okay.
everyone, and
I'll be very happy to answer them. So please, it will be very nice if we can have discussion on these things. Means I've done these things, the test for means. Now go for the weight. If you are taking the same, let us say, weight of the participants, अभी हमने weight ही लिया variable. So in that case, we can divide that data, the data which is with us, into 4 groups. How to divide that data into 4 groups? Maybe 4 regions, maybe 4 languages. According to that, we can have their groups. Okay, and we can compare that weight of all these regions is same or not. Okay. The test null hypothesis will be stated as mu1 is equal to mu2 is equal to mu3 is equal to mu4, and alternative is not all mu's are equal. Now, next thing will be, again and again we are just making the statement that variance is known, variance is not known. Why this variance is important? Okay. Still now we were talking about the measure of central tendency. Now we are talking, we'll go for the variance of the measures of dispersion also. Why this is important? Now look at simple example. Suppose people have lodged complaints about the weight of the 12.5 kg meal bags. There was a complaint. The product is not properly packed, weight is underweight or overweight, whatever the complaint was there. A consultant took a sample of meal bags and did not find any problem with the average weight. A consultant, what he did, he just took a few observations, and when he or she noted down the average weight, it came out to be same. So she could not reject the null hypothesis that the population mean weight is equal to 12.5 kg. What is the problem then? Why the product is not acceptable? Why there is so much complaint about this? So here it comes the problem of variance. The mean is okay in this example, but there could be a problem with the variance. Variation may be more. Whenever the packaging plants are designed, they are designed to operate within certain specified precision. No two products can be same. There must be a small variation will be there in these two products. Variation cannot be zero. नहीं, अगर वेरिएशन जीरो आ गई तो देन देयर विल बी नो प्रॉब्लम, वो हो ही नहीं सकता. Clear? But everybody they try to minimize the variation. Minimum of the variation will be just good for the product, right? So ideally it would be desirable to have the machine pack exactly 12.5 kg in every bag, but this is practically impossible. So a certain pre-specified variation is tolerated. They just pre-specify if up to this much kg, this is 12.5 kg, so maybe 0.2, 0.1, 0.3 kg, up to this much variation is acceptable. So machines are adjusted like this so that variation could not be more. Okay. So this is the test, how we test. After years of operation, it is always important to check whether the machine variation is still at the initially set level of precision. ऐसा नहीं है कि once you set your machine and you go on, because you have to check variation is controlled or not controlled. This is the specification given that it should be sigma naught square, and whenever you collect the data at different times, the variation should come out to be equal to sigma naught square. No significant difference should be there between so here we need to test the variability, okay, against the alternative that sigma square is greater than sigma naught square. Why not less than? Why we are not going for less than? Because if it is less than, then this is acceptable. Variation is less, so less is always acceptable, more is not acceptable, right? So you have to think about these things. Hypothesis को कैसे interpret करना है, कैसे frame करना है इसको, okay? And similarly, let us say we have two machines available in the same factory. We have two machines, and manager is considering which machine is to be purchased, whether to go for the machine A or machine B. Two machines are there. So during test runs, machine A produced sample variance SA square, while machine B produced sample variance SB square. So are these variances significantly different? Which machine should be purchased? Which is having less variation? If let us say we conclude that SA square is less than SB square, so definitely he will go for machine A. If equal thing comes, then definitely anything can be purchased. Okay, so this is how we compare the variance. Okay, so in this case the hypothesis will be stated as that sigma A square is equal to sigma square against the alternative. Of course, this is two-sided alternative is there, but we have to go for one-sided alternative. We'll return to this problem later. Okay, so first thing comes, this is just another examples, because everywhere you want to control the variability. Foreign exchange stability is important in any economy. Too much variation of a currency is not good. Price stability of other commodities is also important. Okay, so similarly you can name other possible areas where you see that variation is to be set at some pre-assigned level. Okay, so this is chi-square test is used when you just check the simple variability, single variability. The null hypothesis is of the form that sigma square is equal to sigma naught square. Whatever variation is specified, that should be put in this value. Sigma naught square is of course known. Need to test this against the alternative that sigma square is more than that sigma naught square. And the test is based on the comparison between S square and sigma naught square. What is S square? This value is computed from the sample, right? And the test statistics which is used is n minus 1 S square upon sigma naught square. Okay, this type of test also you can get from some software. Of course, this is not available on SPSS. Single variance का test आपको नहीं मिलेगा. Comparison of two variances will be there. Okay, but this follows chi-square distribution. Calculate the chi-square statistics. ये chi-square है, थोड़ा curl x होता है ये. This is not written properly. Chi-square, which is n minus 1 S square upon sigma naught square. Now all these values are known. S square you can compute from the given set of observations. Sigma naught square is already given. So under H naught, this is known to have a chi-square distribution with n minus 1 degrees of freedom. And now theoretically, if you want to do this thing, you have to compare this with the chi-square tables. Chi-square tables are available, or use any statistics software to get the p value. SPSS में नहीं है, किसी और सॉफ्टवेयर में होगा. Okay, so p value comes out to be by computing this probability. What happens if this tabulated value is more than this? So this is a chi-square random variable, and this is the shape of the chi-square distribution. ये normal से different होती है. Normal आपने देखा कि symmetrical curve होता है उसका, but chi-square is, of course, it is derived from the normal distribution, but this is positively skewed. And if your value falls in this, if your value falls, the computed value falls in this, you reject the null hypothesis. This represents the p value. This red shaded area represents the p-value. If your value falls in this, you reject the null hypothesis. Otherwise, you don't reject the null hypothesis. एक simple सा example लिया गया packaging machine का जो precision है. देखिए how small is the precision. Sigma naught square is 0.0016. Up to this much variation is acceptable. But from the sample data, it comes out to be 0.0025. So let us see statistically there is a significant increase in the variation or not. Okay, statistically, whether the question is, does this data indicate a significant increase in the variation or not? Okay. See here, after putting these values in the chi-square table, you get the value p-value as 0.143. 0.05 से बड़ी आ गई value. Okay, so p-value comes out to be 0.143. It means no significant increase in the variation is there. Okay, that product should not be rejected. There is no significant increase in the variation. This is how we put the values of the data in this. And then for the two variances, when you are comparing, let us say we just want to compare the performance of the two machines, we just want to put the hypothesis sigma a square is equal to sigma b square with either a one-sided alternative sigma a square is greater than sigma b square or sigma a square is less than sigma b square, or a two-sided alternative. This depends upon the problem which is to be there, and this is the F test. For comparing the two variances, you have to go for F test. Okay, so for two-sided test, you need to pay the attention to both the sides of the F distribution. Yeah. If it is two-sided, both sides are red. Okay, so if your value falls here, you reject the null hypothesis. Otherwise, you don't reject the null hypothesis. Now see here, this is very important to use just the upper tail value. अगर हमने सिर्फ upper tail value use करनी है, ensure that F ratio is calculated so that it is bigger than 1. The variance which is more, that should come in the numerator and the other one in the denominator, and then use upper tail of the this is, you see that whenever you go for two-sided test, the level of significance is divided into half. If it is 5% level of significance for two-sided, on the upper tail it will be 2.5%, and the low tail also it will be 2.5%. Okay, so these are at 5% level, but you must take the ratio bigger than 1 if you want to use the upper value only. Okay. Yeah, thank you. If you want to discuss any other thing, any query, then you can just ask. Actually, I feel that the time is very less to cover all the parametric tests. Or rather, the software technique should also be done simultaneously, so that it will be clear that how to use these things and how to interpret the results. Okay. Now you can come for the discussion. If you have any query, I'll be very happy to answer that. Okay.
Thank you so much, ma'am, for very informative and very detailed session on parametric tests. Now I request to all delegates, because before a practical session, all concepts will be clear. If having any small doubt, you can discuss here, because the last 4 sessions are on practical. On that sessions, you will learn how to apply the test using SPSS and Excel, using pivot table and other things. So before that, you need to clarify all doubts here regarding concepts. If anything, any doubt regarding concepts, you can clarify here. You can write in the chat box, or you can unmute yourself.
Okay, thank you so much. But it will be better if you interact. No, and this is always there in the online lectures, and offline, so at least we can discuss about these things, and the things will be more clear. But anyway,
Definitely, if having any doubt later, I know that in medical fields, some things, something you just get first time. So that's why we provide the recorded session also. So revise again if you miss something, and then if any doubt you can ask. I think there is a query in the chat box from Sweta Shukla ma'am. Ma'am, if there are two groups,
Yeah, I can read that.
yeah.
She is saying that if there are two groups, but we have to check the difference between 81 and 82 and 83. When there are two groups, then definitely we'll be having the two groups only, R groups. If there are two groups, है ना, तो definitely the two groups will be there. Then there is no question for checking this thing. देखिए ना, इंट्रा एंड इंटर ग्रुप में क्या होगा? इंटर ग्रुप में तो अगर आपने सेपरेटली चेक करना, दैट इज देयर, बट यू हैव टू कंपेयर द टू ग्रुप साइमल्टेनियसली. नो, एम आई राइट? टू इंडिपेंडेंट ग्रुप्स है ना आपके. वी आर नॉट टॉकिंग
यस मैम.
अबाउट, हाँ, डिपेंडेंट ग्रुप्स की नहीं बात कर रहे.
मैम मेरे दो ग्रुप है. जैसे फर्स्ट में मैंने जैसे मेरा डायबिटीज टॉपिक है, तो फर्स्ट ग्रुप में मेरी एक क्लासिकल मेडिसिन है एंड सेकंड ग्रुप में मेरा मेटफॉर्मिन है. बट जो फर्स्ट ग्रुप या सेकंड ग्रुप जो भी लेते हैं, उसमें मैंने जो 30 डेज का असेसमेंट किया है, तो यदि मुझे बीटी 81, 82, 83 एंड फॉलो अप पीरियड में देखना है कि कितना चेंजेस आया है बीटी से 81 या 81 से 82 में, तो इस पर्टिकुलर कंडीशन में मुझे कौन सा टेस्ट अप्लाई करना चाहिए?
नहीं, आपका जो एक ग्रुप पे आपने एक ट्रीटमेंट अप्लाई किया है ना,
हाँ जी.
और दूसरे पे डिफरेंट किया.
हाँ जी.
हाँ, तो दोनों का डिफरेंस जो चेक करना है, इंडिपेंडेंट ग्रुप्स है ना.
हाँ जी. नहीं, वो तो मैंने मैन विटनी एंड विल्कॉक्सन किया ही है. इंट्रा
मैन
ग्रुप में
विटने
मैंने
विल्कॉक्सन
विल्कॉक्सन
आपने
एंड
तभी,
पेयर्स.
देखिए आप बात कर रहे हैं विल्कॉक्सन मैन विटने की, दैट इज वेरी इंपॉर्टेंट, आपका नॉन पैरामेट्रिक में डिस्कस होगा. इट मींस
हाँ जी.
नॉर्मेलिटी इज नॉट देयर इन द डाटा. ठीक है
हाँ
ना.
जी.
आपका डाटा इज वेरी स्मॉल बिकॉज इन मेडिकल फील्ड वी कैन नॉट टेक लार्ज डाटा.
हाँ जी.
There the data is very small, so we can compare by using non-parametric tests. जहाँ
हाँ
small
जी.
sample size है और normality नहीं है, तो you have
हाँ
very
जी.
rightly used Wilcoxon man-Whitney test. This is a
हाँ जी.
counterpart of this T test for two independent samples.
हाँ जी. हाँ जी.
है ना, तो you are doing it correctly. तो
यस.
इसमें यही आएगा आपका.
नहीं, ये तो मैम मैं कर ही रही हूँ. जैसे कि बीटी और एटी में तो कर ही रहे हैं, बट यदि मेरा जैसे 30 डेज पे असेसमेंट मैं कर रही हूँ, तो मैं ये चाह रही थी कि बीटी से 81 में कितना चेंज आया, 81 से 82
ये
में,
कितना
और
चेंज
82
है,
से
we
83
cannot
में कितना
measure
चेंज आया.
that. We cannot measure that. अब मेजर नहीं कर
अच्छा.
सकते हम, सिर्फ ये कह सकते हैं कि देयर इज ए चेंज, बेटर है या
अच्छा.
वर्थ है, वॉट एवर, वी कैन जस्ट से दैट इम्प्रूवमेंट है और नहीं है. बट मेजरमेंट नहीं है कि कितना चेंज आया है
हाँ,
इसमें.
नहीं नहीं, मतलब मेजर नहीं करना, बट यही देखना है कि इज देयर एनी सिग्निफिकेंट चेंज.
या दैट यू कैन चेक ना. जैसे वो मैंने आपको बताया कि आप वन साइडेड अल्टरनेटिव में जाएंगे,
हाँ जी.
you feel that in this there is a change, better change is there, that one sided alternative can be there, उसमें एवरेज को आप बड़ा रखेंगे.
हाँ
Okay.
जी.
I'm not clear about your problem and parameters. तो
हाँ
उसके
जी.
अकॉर्डिंगली आप अल्टरनेटिव फ्रेम करेंगे. बट आप एक चीज ध्यान रखिए कि व्हेन यू गो फॉर वन साइडेड अल्टरनेटिव यू कैन नॉट यूज सॉफ्टवेयर डायरेक्टली. जो जितने भी सॉफ्टवेयर हैं ये टू साइडेड वैल्यूज ही देते हैं आपको.
अच्छा.
राइट. तो उसमें
ठीक
आपको
है.
फिर ये पूरा, तभी मैंने थोड़ा सा कंसंट्रेट किया इसमें थेरेटिकल चीज़ों पे, ताकि आप
हाँ जी.
स्टैटिस्टिक्स से, ऑफ कोर्स फ्रॉम द सॉफ्टवेयर यू कैन पिक द वैल्यू ऑफ द टेस्ट स्टैटिस्टिक्स. Then
हाँ
for
जी.
comparison person for purpose, for the decision making purpose, you have to go for the tables and all. उसमें वन साइडेड का नहीं दिया होता, टू साइडेड ही है. एवरी सॉफ्टवेयर गिव्स टू साइडेड alternative,
ओके.
but especially in these medical fields you have to use one sided. तभी आप डिसाइड करेंगे which procedure is better. No,
ओके. तो
which
मैम ये
treatment is
वन
better.
साइड ऑल्टरनेटिव जो है, ये मतलब एग्जैक्टली इस प्लीज थोड़ा सा इसको क्लियर कर दीजिए, ये मैं थोड़ा सा नहीं समझ पा रही हूँ.
अभी ऐसा है कि you can have my number anytime, we can discuss that. अभी बाकी लोगों को हम वो ना करें इस चीज में, because you are discussing your
श्योर.
personal problem, है ना. तो
Dr.
ओके.
Sweta,
ओके.
you
हाँ,
just message me. I will provide you. I will provide your answer with your queries.
you can
ओके.
always discuss.
थैंक यू.
These are very
Yeah.
small things and I am very happy कि आपको इसको properly use करना चाहिए statistics को,
हाँ
तभी
जी.
इसका
हाँ जी.
फायदा है.
ओके. ओके.
ऐसा नहीं है कि रिजल्ट पहले माइंड में सोच लें और उसके हिसाब से डाटा बना के आप रिजल्ट्स दे दें.
हाँ जी.
हाँ, अभी किसी एक नेक्स्ट क्वेश्चन इज व्हाट इज वेरिएंस एंड व्हेन डाटा से नॉर्मली डिस्ट्रीब्यूटेड। वेरिएंस तो ये तो आपने बहुत बेसिक चीज पूछी है। जैसे वेरिएंस है बिकॉज वेरिएबिलिटी क्या होती है डाटा में, नो टू ऑब्जर्वेशंस कैन बी सेम। अगर आप उसको फाइनर स्केल पे मेजर करते हैं, वेट भी अगर मैं मेजर कर रही हूँ, हम कह देंगे कि दोनों का 65 kg है, बट दैट मे नॉट बी एग्जैक्टली, सम वेरिएशन इन दैट इज देयर। whenever you measure certain thing you cannot have all the observations equal. अगर सब observations equal होगी तो then variance becomes zero. और अभी आपको तो बिल्कुल मुझे लगता है कि डॉक्टर जागृति कुमारी है। तो ये दीज आर द बेसिक थिंग्स। अभी आपके इतने लेक्चर्स हो गए हैं स्टैटिस्टिक्स में। नॉर्मल डिस्ट्रीब्यूशन, जैसे कल के लेक्चर में भी मैं देख रही थी, उन्होंने नॉर्मल डिस्ट्रीब्यूशन के ऊपर बहुत डिस्कशन की। नॉर्मली विज्यूम नॉर्मल डिस्ट्रीब्यूशन फिनोमिना में हम कहते हैं कि इट फॉलोज नॉर्मल डिस्ट्रीब्यूशन फ्रॉम नेगेटिव वैल्यूज टू पॉजिटिव वैल्यूज, इक्वली सिमेट्रिकल डिस्ट्रीब्यूशन, सेंटर में इट गोज, इट टेक्स द पीक एंड ऑल। बट जैसे मैंने बोला कि प्रैक्टिस में इट इज नॉट पॉसिबल दैट इट फॉलोज नॉर्मल डिस्ट्रीब्यूशन। उसमें कोई डिफरेंट, देयर आर सो मेनी अदर डिस्ट्रीब्यूशंस व्हिच आर देयर। तो नॉर्मलिटी आपको चेक करना है। नॉर्मल कर्व है, सिमेट्रिकल कर्व है, दैट यू कैन ऑलवेज चेक फ्रॉम योर डेटा। आप मैनुअली उसको प्लॉट करके देख सकते हैं। जैसे इफ यू गो फॉर फ्रीक्वेंसी डिस्ट्रीब्यूशन टेबल, देन प्लॉट द frequencies and see what is the shape of the curve. Otherwise there are so many plots, pp plots, qq plots there, and some tests are also there to check the normality. Non parametric में आप करेंगे chi-square test है, goodness of fit, chi-square goodness of fit test is there, Kolmogorov-Smirnov goodness of fit test is there, which gives whether the distribution is normal or not normal. Okay, right?
I hope Dr. Jagrati, you just revised previous 3 or 4 lectures of descriptive statistics. I think
Yeah.
you missed that session. So
No,
that's why
that must be there, because they should be clear about the basic statistics. That's why I just revised all these things. मैंने उनके ऊपर ज़्यादा concentrate नहीं किया।
yes, definitely.
ये पहले वाले थे। I thought कि they have done this thing. How to collect the data, what are the different scales for the
Yes,
collection of the data.
definitely.
All these things I skipped.
These things already done, and I hope Dr. Jagrati, you missed the session. So I request all delegates, if you missed the session, because everything is in continuous manner. If you miss anything, then it's difficult to understand the next concept. So
Yeah.
everything is connected, as in the last session sir also said that every lecture is connected to each other in statistics.
अभी मैंने आपको बोला कि नेक्स्ट विल बी नॉन पैरामीट्रिक पे जब आपका
Yeah.
होगा, तो इन नॉन पैरामीट्रिक इन्फरेंस, नॉन पैरामीट्रिक मेथड्स, यू विल बी डूइंग ऑल दीज अल्टरनेटिव मेथड्स। जो अभी हमने जितने टेस्ट आज किए हैं फॉर द सेम नल हाइपोथेसिस, अल्टरनेटिव हाइपोथेसिस, यू विल बी हैविंग अ नॉन पैरामीट्रिक टेक्निक। When the assumptions are not met, you will go for the non-parametric technique. So all these things are connected. अगर आपको पैरामीट्रिक के बारे में नहीं पता तो आप नॉन पैरामीट्रिक कैसे करेंगे, right?
Correct. So I request to all delegates, as our last month is totally concentrated on the research writing, and this month is totally concentrated on the statistics, biostatistics, data analysis, and all things. So if you missed any session, so please revise. From the 1st July, we started the session 4 on statistics and biostatistics. So if you missed the session of basic statistics, you just go to the previous recordings on 1st July till now. Then you are able to understand clearly all concepts in today and the further lectures. So thank you very much, ma'am, for delivering a wonderful session and for sharing expertise with all delegates in this program. It's a very enlightening session, and it's very thankful for your presence in this program.
Thank you so
Thank
much.
you.
Thank you interacting with you and associating with you. Thank you so much. So now I should leave, I think.
Yeah, ma'am. Thank you so much. On the behalf of organizer, we again thank you so much for your presence, ma'am. Thank you.
Thank you very much. Thank you.
All delegates, this is the end of today's session, and the next session will be scheduled on Monday, and it will start at 6 p.m. and we move towards the testing of relationship for parametric and non-parametric in continuous manner. there are 3 sessions on inferential statistics. I always repeat this sentence that if you miss the session of statistics, because these are interrelated to each other. If you miss the session, so please, I request to revise from 1st July, because this month we move on to the statistics and biostatistics part. And this is the main part of your, if you are doing any research like thesis writing, paper writing, if you are able to do analysis by yourself, then you need to revise the session from 1st July. If you are need to concentrate on research writing only, then you will revise the session of last month, June month. So thank you everyone for feedback in the chat box, and thank you for listening all sessions very patiently. And I think sometimes the session goes long as per the topic, and sometimes the session completed before time. So it's depend on the content and the topic as per the schedule. Thank you everyone. This is the end of today's session.